Schneider Electric's very own solar applications engineer. So Eric, thank you for joining us, and I'm passing it over to you.
Thanks, Hannah. Hello, everyone. Again, my name is Eric Benson. I'm a sales application engineer for Schneider Electric. I've been with the company for 13 years, and I know our product lineup very well. I want to thank the good people at AEE Solar for allowing me the opportunity to share with you today. And I want to thank our channel sales expert, Rob Coates, for arranging this training session. In this webinar, we will talk about the monitoring options available for the Conext line of residential and off-grid solar products. I don't want to second guess the knowledge level of our attendees, so we're going to start with a product overview so we know what products are actually being monitored, after which we will show some typical configurations. Then we're going to focus in on the monitoring solutions we offer. Finally, we will showcase a few systems if we have time, and hopefully we'll also be able to get to as many questions as possible. The XW Plus is king of the hill when it comes to versatility, reliability, and robust design. Based on the original legacy XW, this inverter charger has stood the test of time with literally thousands of systems installed around the world. We call the XW Plus a hybrid because it's bidirectional, meaning that it can take power from the grid to charge the battery, or it can take power from the battery to reduce the draw from the grid, and even export excess power. The XW Plus is single-phase by default, but it can also be configured for three-phase. The power distribution panel makes installation a breeze for single-unit systems up to and including triple inverter configurations. The standard power distribution panel provides split-phase AC breakers, and we also offer a power distribution panel without AC breakers, so the three-phase breaker kit can be specified. The standard power distribution panel is perfectly suited for dual XW Plus systems when adding the second inverter connection kit and the 12240 AC breaker kit. The standard power distribution panel is great for single XW systems where the customer may wish to expand at a later date. However, the mini power distribution panel is a cost-effective solution that provides easy and fast installation of single XW Plus systems. Mounting directly beneath the XW Plus, all the breakers are pre-wired and ready to land on the AC terminal block of the XW. The Conext SW is a cost-effective solution for small to medium load demand. Available in 24 and 48 volt models, the Conext SW is packed with features that increase the value to the end customer. Split-phase power will accept a single-line 120 volt AC source and still provide a split-phase output due to a built-in auto transformer. AC support and load shave allow battery power to be prioritized over grid power. Conext SW can be used AC coupled or in DC coupled applications. Integrated AC and DC switchgear is available for fast and easy installation. Schneider Electric offers two models of maximum power point tracking solar charge controllers. The MPPT-60, which provides 60 amps to the battery, assuming the array is appropriately sized, of course, and the MPPT-80, which is our high voltage controller. Both are proven designs with a reputation for being robust and efficient. The system control panel allows user programming of all XW devices in the network. The automatic generator start can be programmed for any one of 14 different generator types. Start triggers are voltage, load, and state of charge percentage, which requires the battery monitor. The battery monitor provides an accurate account of battery statistics. We should also mention that the battery monitor state of charge percentage can be used to trigger the auxiliary port. Before we focus in on the ComBox, let's talk about a couple of typical system configurations. Here we see a diagram of a typical grid-connected DC coupled system. When DC coupling, the PV supplies the charge controller, which in turn regulates to the battery and protects from overcharging. The XW will then take that energy to prioritize the battery power over the grid power to satisfy your AC load demand. And if you're set up to sell, then any excess power being generated that your subpanel does not consume will be exported back towards your main panel and then ultimately to the grid. When AC coupling, we are merely inserting the XW Plus or Conext SW into an existing system. All we are doing is dedicating a breaker in the main panel to the input of the battery-based system. Then we're adding a subpanel to dedicate the critical loads. This allows the battery-based inverter to fool the grid tie inverter into thinking the grid is still present, allowing PV production even when the grid is down. Now let's talk about monitoring. The Conext ComBox is a TCP over IP device that provides local monitoring with a data push to the cloud, which is called Insight. More on that in a few. The ComBox allows access to the menu structure of all ZAMBus devices in the network. It is important to note that third-party charge controllers and/or battery monitors will not be recognized by the ComBox. Firmware upgrades are an important benefit because it's always the best practice to have the latest firmware in all the devices. Just because a unit is new in the box does not guarantee it has the latest and greatest. Emails can be sent to report production and faults. Custom data logging is an invaluable tool in diagnosis of unusual behavior. File transfer protocol is just another means of logging specific data that may be useful. Finally, the dry relay contact can be set to trigger an alarm if a fault occurs. First time setup of the ComBox is easy. Just plug the ComBox and laptop into a router. If a router is unavailable, we have a download on the website that allows for direct connect from the ComBox to your computer. When performing firmware upgrades on the XW Plus or Conext SW, it's important that the router has power from an external AC source that may be bypassed if it's out on the output side of the inverter, because the inverter is going to be inactive during the upgrade process. The ZAMBus network is simply a daisy chain of devices using Ethernet cables. Each device has two ZAMBus ports, so there will always be an open port at either end of the network that must be terminated. Each device ships with a network terminator. The XW Plus, Conext SW, and MPPT-80 are the only devices that supply ZAMBus power. ZAMBus will power the ComBox, but the ComBox cannot power ZAMBus, even with the AC adapter. Once the ComBox is booted, simply insert the supplied thumb drive into the host port and wait for the memory LED to blink 5 times. Then remove it and plug it into your laptop. When you open the contents of the thumb drive, you will find an HTML file that is the same as the serial number of the ComBox, which is the letter B followed by 8 digits. Then just click Connect. Here's a screenshot of the login. Subsequent attempts to log in will be met with an alert to change the password, although the ComBox settings menu also provides this capability. Of course, you can always click Skip if you want to keep it at default. Once logged in, the system status page appears. Here we see mapping of the devices and direction of power flow in watts is displayed in real time. Note the battery voltage, amperage, state of charge percentage, and temperature that is reported by the Conext battery monitor. On the left side of the web page, you see all the ZAMBus devices in the network. So you'll note that this is a triple XW system. We've got one high voltage MPPT controller, a battery monitor, system control panel, and an automatic generator start. Here we see the device status screen for the XW Plus, which provides a wealth of real-time information about the state of the unit. AC and DC voltages, currents and power, fault status, firmware, Modbus address, etc. So say a customer called in and said, hey, my system isn't selling, it would be very quick and easy just to access this device status page and go down to see if cell is enabled. And if it's disabled, it's just a matter of enabling cell mode and he's back in business. Likewise, we can see in this particular case that the charger status is absorption, so it is in a charge mode. We have many other parameters that at a glance in this device status page, you can see what's going on with that device in real time. Drilling down into the XW Plus settings menu, we see all the relevant settings applicable to system setup and control. So for example, controls would allow you to access inverter enable or disable, charger enable or disable, grid support, cell mode. Inverter settings would have low battery, high battery cutout settings. Charger settings would allow you to set up for battery type and capacity. The custom battery menu is very nice because in case the default settings do not apply to the recommended charge parameters offered by the battery manufacturer, you can always just manually enter those values in the custom settings menu. And then you have AC settings, which establishes your high and low voltage and frequency limits. Active power control, that's for your AC coupling curtailment feature. Grid support, that establishes the level that the batteries will stay when supporting the grid. Generator support, in case you have a generator that needs some help from the batteries from time to time. And the auxiliary relay has many parameters that you can program to trigger an external device. It also works with state of charge percentage if you have the battery monitor. Multi-unit configuration when you're configuring multiple units. Associations in case you have multiple battery banks or loads. You can assign, you can associate different inverters and different charge controllers to external sources and loads. And then of course advanced features, which gives us parameters such as load shape delay, which allows your system to allow the batteries to recharge before it starts to use battery power. There's other advanced features that we're not going to dive into at this time, but I'd invite you to go into the manual for the XW and check it out. The events list real-time and historical faults and warnings for each device. So we can see here that we've got some system configuration faults. This is the system in Costa Mesa. This is our test lab. Many times it's necessary to disconnect a particular inverter, reduce the triple inverter size maybe down to a single unit to simulate a particular scenario for a customer. So here we can see that over a particular range of time that there were some system configuration faults, DC over voltage or certain things. But anyway, this is a great source so you can go back and see what's been going on with the XW or any device that's in the network for that matter. The ComBox status screen shows all the Zambus devices with their unique ID and Modbus address. Also listed is the ComBox version, which tells you if you have the latest ComBox firmware. Here we see the settings for the ComBox. Time and zone can be entered manually or display network time with an internet connection. TCP over IP settings allow setting up a static IP for port forwarding through a VPN router. Email setup allows for production reports and fault status to be sent to select individuals. Also file transfer protocol setup and dry relay contact setup. And by the way, these screenshots are from a system that's in Costa Mesa. I happen to be in Washington State, so I'm on the Schneider Electric network, and I can log into this system anytime, change settings, do whatever I need to do, and it performs certain tests from 1,000 miles away, so that's actually pretty cool. Also included in the ComBox settings are the ability to suppress faults and warnings for a particular device. Say you have an external device that's starting your generator from time to time, but it's not through the AGS. You're going to get a warning that says the generator started, but not through the AGS. So things like that, if they can become a nuisance, then you can just go ahead and suppress that particular fault or warning. You can also set up for Modbus Communications in case you have external RS-485 devices that you want to add, which includes power meters, pyrometer for measuring temperature, and we also have the Conext Insight web portal data push for setting up for Insight. We'll talk more about that in a few. Curtailment, which is related to AC coupling. It's actually a frequency shift, so in a backup scenario, the XW shifts the frequency once both voltage is reached to protect the battery. So the grid tie inverter is going to respond one of two ways. Depending on whether it has curtailment capability, it'll either throttle down the output or it'll shut off and count down for 5 minutes and come back online. Firmware upgrades are a snap with the ComBox. Just upload the relevant firmware file and select the appropriate device from the drop-down menu. It's also worth noting that the ComBox is now able to recover bricked units that result from an incomplete firmware upgrade. Remember, we talked about making sure the router stays powered during a firmware upgrade? Before, we used to have to ship a special tool for recovering such. Thankfully, that is no longer necessary. Like the devices, the ComBox also has a time-stamped event log. This is from the Costa Mesa lab. We can see the system was powered up at 8 a.m., then rebooted, and followed by repeated logins by yours truly. Again, I can remote into the system anytime I want. And likewise, if you wanted that capability, Schneider Electric does recommend the use of a VPN router for security, because when you're port forwarding, you're opening up a port into your local area network to the outside world. So you want there to be a level or a layer of security to require a login so you can access that local network externally. Custom data logging allows specific parameters to be monitored over time. This requires a micro SD card to be inserted into the ComBox. This can be extremely helpful when troubleshooting from a remote location, saving time and money and possibly eliminating return trips to the site. Logging of the entire system or individual devices is possible with a granularity as low as every 5 seconds. File creation can be hourly, daily, or monthly. So we can see here any device you can set to log whatever parameter you want for that device. For example, AGS, you might want to know why it started. Maybe you have the AGS set up to start on load and trigger on state of charge percentage, and the customer says, hey, the generator keeps starting, and you can go in and see if the trigger was low voltage or low state of charge percentage, or if it started on a load. So virtually any parameter for any device that you can do the custom data logging and at whatever granularity you want to get the data necessary to make an informed decision about what's going on with the particular system. Here we see a log of a 2-hour discharge test for California's SJIT program. which resulted in a significant payback. This showed that we could power between 7,000 and 8,000 watts for 2 hours. And again, it is directly related to the amount of payback that California provides under this program. This happened to have been a 1100 amp hour Deca Unity 2 battery bank. This example shows a dual XW system with uneven discharge from 2 separate battery banks. The system was load shaving during this period. So we can see that in the upper portion we have the differential in bank voltages, and we also, the differential in battery bank power levels, as well as a differential in load power. So when we logged the AC voltage, it revealed a differential in AC voltage between the 2 inverters as a result of a bad connection. The problem was solved, resulting in more balanced sharing of the load between the 2 inverters. And by the way, this is just one example of the myriads of different parameters that you could monitor to troubleshoot a particular issue. The ComBox also provides energy graphing for the relevant ZAN bus devices in the network. Here we see a battery energy versus power sold for the month of April. And again, this is not your typical system. Normally you'd see higher levels of selling, but this is our Costa Mesa lab, but this is just kind of honing in on the different parameters that you can select from to monitor. Here we see a PV input comparison between 2015 and 2016. They use solar simulation software in the lab in Costa Mesa. So rather than having a PV array on the roof, which would be nice, but never happened, they have software that they can just ramp up a simulated PV output to the MPPT-80, and it'll power track and do whatever we need it to do. PV and AC daily summary provides a snapshot of load watts, grid net watts, generator watts, and total PV watts. So not a lot going on with anything here except for the grid power. We can see the charger ramped up at 7 a.m. and then it gradually tapered off through the absorption stage. Battery bank daily summary provides voltage, current, battery temperature, and state of charge percentage, assuming you have the battery monitor in the network. Here are the specs for the Conext ComBox. So in particular, we might want to talk about the low power consumption, less than 2 watts is typical. RS-45 connector is available for RS-45 Modbus Communications. It has a micro SD card port for custom data logging, 96 megabytes of flash memory. We do have Android version, Ice Cream Sandwich 4.0 for the Android app. The size and weight are listed. NEMA, indoor only. These are not outdoor rated devices. Status display, part number, remote firmware upgrades, yes. Custom data logger, yes. 5-year warranty. Conext Insight is a cloud server that provides remote monitoring for single or multiple sites. Device status can be observed as well as energy graphs and events. We have an app for the Android tablet. A lot of folks have asked me, hey, are you guys coming up with an app for iPhone or Samsung or whatever? And it sounds good on its face, but when you think about the menu structure of ComBox and all the sub-menus and whatnot, to me it seems like it would be very difficult to see on the small screen of a mobile device like a cell phone. But we've heard the cries for such an app, and they may be working on something that's a little more or a little better suited for something like a handheld cellular phone. Once you set up the ComBox for Insight, you will get a login screen like this. In fact, we have a demo system on our website, sesolar.com, in case you care to navigate through the different functions and features of the platform. In the demo, you can see the battery-based system is differentiated from the sites that have string inverters. Note in the little green box there, you've got a symbol of a battery in the upper right. Also note that the site will turn a different color depending on the situation. Green is good. If it's orange, then there's an active error at the site. If it's yellow, then the site is connected to Conext Insight, but there's a warning at the site. It also shows you if there's no data transfer, maybe there's a problem in communication. The site summary screen shows an overview of the entire system with energy totals for each. So you can see you've got solar. If you have solar charge controllers, that would be populated. Whatever load would be showing up in kilowatt hours. You'd have your grid imported and exported showing up separately. If you incorporate a generator, that would also show up. And then, of course, your battery energy. Solar energy graphs display daily and historical production. Graphs can be displayed for a particular date, month, year, or lifetime. Here we see a battery energy graph for this month. Notice the real-time battery voltage is displayed in the upper right. We can verify each device is working properly by the green check mark on the device status page. If any device has a red X next to it, we'd be able to see the active fault code listed in the events section. Note the historical faults are also logged. And if a device has a yellow exclamation point, we would see that device listed in the active warnings section. And again, we have historical warnings listed as well. Multiple sites may be added to any Insight account. Notice the site locations are identified with GPS coordinates, which is automatically determined once the site address is entered during initial setup. And multiple ComBoxes may be added to a site, which is true at Institute of Technology in Chicago. They have a gym with 18 kW LED lighting, which power is offset over a 4,000 amp hour battery bank and 20 kW of stored of solar energy. Here we see a 6XW system at the Institute of Technology in Chicago. We have one ComBox dedicated to the 6XW Plus inverters and a second ComBox dedicated to the 6 MPPT80 charge controllers. There's also a secondary backup system in the north battery room that also has a dedicated ComBox. So when we're talking about using multiple ComBoxes, there's a limit to how many ZANBus devices that you can accommodate in a single network. So that's why we offer the ability to have master and slave ComBoxes. These photos were taken last year when the system was commissioned. You can see the charge controllers on the right, inverters on the left. So this shows a screenshot here of what we call a multi-cluster. This is an example of multi-unit XW system where you could have up to 12 XWs and up to 16 MPPT-80 charge controllers. So if you follow the blue line, you can see that the inverters are in the network daisy chained with the battery monitors, and those are all dedicated to one ComBox. And then all of the solar charge controllers are dedicated to a second slave ComBox, and then a master ComBox is used to aggregate the data from both slave ComBoxes onto a single web page. This is a 9XW multi-cluster in Irvine, California with 3,200 amp hours of lithium iron phosphate batteries and 39 kW of PV power. A custom-made AC combiner box is needed to switch more than 60 amps per phase. So we partner with panel builders to custom design solutions for these larger systems. So just to kind of give you guys an idea of what's possible. Here's a photo of the lab in Costa Mesa. The guys in tech support have access to the system to simulate many different scenarios. So if somebody calls into tech support and they say, hey, my inverter is doing such, then they can simulate the scenario usually in the lab and confirm whether that's normal operation or not. So it really gives the guys in tech support some great tools to offer an exceptional level of support to our customers. Here's the Conext SW system in the lab. You can see we got a ComBox dedicated to it, as well as a ComBox dedicated to the XW system. And here's the CL string inverters with the discontinued GT and TX models, but they're there for reference. And again, you notice that Insight also had sites created for the CL. So if anybody's interested in string inverters, it is possible to set those up with Insight as well. And it looks like we've got plenty of time to take questions, and I really like getting a lot of questions because we want to make sure we're answering specifics from our attendees. So from what I understand, Hannah will be able to field those questions and then forward them to me, and I'll be happy to start taking questions now.
Great, thank you, Eric. That was a great informative presentation. So we will start off with our Q&A session. We received quite a few over the course of the presentation, so thank you so much for submitting to those of you who did. If you do have any more questions, feel free to keep sending them over, and any that we don't get to, we'll be sure to follow up with after the presentation. All right, well, we'll go ahead and get started. Eric, our first question is going back to the charge controllers and asking what string sizes are allowed for the charge controllers?
Oh, that's a great question. So we offer two models of MPPT charge controllers. Let me go back to the screenshot here. So the MPPT-60 is a relatively lower voltage charge controller. It accepts up to 150 volts DC maximum, and that's an absolute maximum. So you want to make sure that you calculate your record low temperature for the area that the system is going to be installed, and then calculate your maximum open circuit voltage. And likewise for extremely warm areas, you want to go the other direction. You want to count the, you want to calculate the VMP percentage in the hottest temperature to make sure that if your array is configured toward the lower end of the power tracking spectrum, that you don't fall into a region where the maximum power voltage is too low. So when I say too low for the MPPT 60, we want to make sure that it's power tracking at the very least 10 volts higher than the bulk voltage that you're trying to target. Because the MPPT 60 has what we call a buck transformer. So the array voltage always has to be higher than the battery voltage that you're targeting. And then likewise for the MPPT 80, that's what we call our high voltage charge controller, where the array can be configured up to 600 volts DC. And again, that's an absolute maximum. So make sure to do your VOC calculations in record cold temps. And on the other end of the spectrum, if you're in a hot region, for VMP. And the power tracking range for this model is 195 to 550 volts. I hope that answered your question.
Great, thank you, Eric. The next question we have, for the California SGIP program, in order for a battery system to be considered paired with renewables, the battery must be charged at least 75% by the renewable source. Can the Conext Plus prevent the local electric grid from charging the batteries so that only the solar charges the batteries?
Absolutely. You can set charger block in case you wanted to only use the grid to charge at a particular time when the rates are lower. So that's a great question. Yeah, the XW Plus and the Conext SW are extremely versatile in that you can actually set them up to charge when you need to. You can also set up for load shaving, so it prioritizes battery power over grid power during periods where rates might be higher. So yes, absolutely. That's a great question.
All right. And our next question. In a DC coupled configuration, once the battery is charged, does the charge controller shut down, or does it continue to push current if loads in the system can use it?
So we're getting some great questions here today, Hannah. So whether the charge controller is going to regulate, meaning reduce the output, is going to be dependent on whether you're set up for selling or not. If you're set up to sell, then virtually all of your solar energy is going to be used to support the grid, prioritizing your critical loads first, and then exporting any excess. And then, of course, your main panel is going to consume whatever loads are present there. And if there should happen to be any power left over after that, it'll turn your meter backwards. So when you're talking about not selling, then once the batteries are full, your solar production is going to be commensurate with your load demand because the current has nowhere else to go. So for example, if you're producing 3 kW of solar and you've got 1,000 watts of load and your batteries are full, then your charge controller output is going to drop to 1,000 watts. And again, assuming the batteries are full. If the batteries have a way to go to charge, then obviously the solar energy will continue to charge the battery, and whatever's left over will be used to support the load. So I guess it all boils down to whether you're selling or not. Good question.
Yeah, I know some really good ones that are coming through. The next question we have, how many devices can a single ComBox support?
Great question. So typically your ZAN bus network has a bandwidth of 20 units. The inverter chargers require 3 units, and then all the other accessories, including the charge controllers, require a single unit of bandwidth. So the largest system that I've personally experienced in a split phase configuration is 3 XW inverters and 8 MPPT 80 charge controllers. Then you start approaching the limits of what a single network can do. Again, network stability is also dependent on whether you're being diligent in routing your cables, making sure that you're routing them through the grounded raceway, also making sure that the SAN-bus cables are not routed in parallel with any AC conductors. That's another big one. And then, of course, the quality of network cables always is a top consideration because, you know, just because you get a network cable that's new in the bag doesn't mean it's good. It doesn't, you know, I've run into bad network cables that were new quite often. Or when folks make their own Cat5 cables, sometimes that runs into problems as well. So always make sure your network cables are in good shape, and always make sure your network is terminated. We talked about daisy chaining the network in SAN-bus and making sure that all of your network terminators are in place. That's a big one. That's the diagram I was talking about. So no matter how many SAN-bus devices you have in the network, there's always going to be an open port at either end of the network, and those must be stuffed with network terminators. Great question.
All right, and just before we dive into some more, I just want to remind everyone that when you exit the webinar, there will be a brief survey that will pop up. So just, I think, 4 or 5 questions really quick. If you could just answer those, I'll send you a copy of the presentation later today. All right, and we'll keep diving into some more here. Eric, our next question is, does the router have to stay powered up during a firmware upgrade? Should they put the system in bypass mode?
Yes, absolutely, and yes again. That has been a sticking point for many off-grid, especially installers, where you start the upgrade process and the inverter loses power, and the inverter just happened to have been powering the router. So then the upgrade process is interrupted. Then the device doesn't know what model it is. It'll know it's an inverter, but it won't know what model, or if it's a charge controller, likewise. So before, it was necessary to call tech support, and they would set the customers up with what we call Conext config tool, which is a dongle that connects between your laptop and the device in question, and then you could recover it that way by just selecting the right firmware file and downloading it. We have since corrected that with the ComBox to where they have a program that will allow recovery of a bricked unit using the ComBox. So that's a great feature. But yeah, absolutely, if you're off-grid, or if the router happens to be powered from the output side of the inverter and you need to upgrade the power producing device, which is the inverter providing AC to that router, then make sure you're bypassing the XW system if you're on grid, or make sure you're bypassing the XW system with your generator if you're off grid. Great question.
Okay, next question. Can the Conext Plus be configured for 120, 240, 3-phase, 4-wire delta with 208 high leg?
No, not delta, not any delta configuration. This is a Y configured 3-phase system. So by default, the XW Plus comes 120, 240 split phase. In order to configure for 3-phase, you have to convert each unit to 120 volts. By convert, I mean installing jumpers that short L2 to neutral, and then you move a couple of wires on the AC board going to the transformer, and then you upgrade the firmware to 120 volt firmware, and then essentially you're left with a 120 volt AC inverter. Then you take 3 inverters that have been configured or converted to 120 volt AC, and you assign L1, L2, and L3. So essentially what you end up with is three 120-volt inverters that just happen to be phased 120 degrees apart. So for that reason, they all have a common neutral, and that is compatible with a Y-configured transformer. That's a great question. I hope that answered it adequately.
Great, thanks, Eric. The next question. Can the system measure round-trip efficiency to the batteries?
Indirectly, you'll be able to see what the PV output is in watts, and then you'll be able to compare that to the wattage going to the battery. You can log all those parameters with custom data logging. I guess it depends on what parameter you're looking for. It will show you the watts without custom data logging. If you're looking for amps, volts, that's something that you certainly could program using custom data logging. But as we showed you before, you'll be able to see, every device that's in the network, and you'll be able to see that device's respective output wattage. You'll be able to see the inverter power. If it's a charge controller, you'll be able to see the PV power separate from the battery power. So, you'll just have to divide the output by the input to get your efficiency.
All right, thank you. The next question, can the SW inverter sell power to the grid?
Absolutely. Yes, the XW is the only model that has the ability to export. Conext SW, Sam Whiskey, does not have the ability to export, but it can do load shaving, time of use, it can AC couple. So Conext SW is a very cost-effective solution, just packed with features. But if selling is something that you wish to do, then you're going to need to head toward the XW.
All right. And does the MPPT-80 have cooling fins?
No. The MPPT-60 is the one that has the cooling fins on the left there. So it's passively cooled. No fan is incorporated in this particular model. The MPPT-80 does incorporate a fan, a single fan that pulls the power up through the bottom and exits out the top. So that's a great question. And so you're looking at two different ways of cooling. MPPT-60 was actually released with the legacy model back in 2007. So it's virtually unchanged in its design. It's proved to be very reliable and robust. The MPPT-80 was released around 2012. So incorporating the high voltage controller did require implementation of a fan. But yeah, that's the main difference between the two, is the 60 amp model is passively cooled, the 80 amp model is actively cooled. Good question.
All right. And the next question, has Schneider prepared a document we can submit to the SGIP for Section 5 Preliminary Monitoring Plan?
Have we prepared a document for SGIP? Not that I'm aware of, but I can certainly look into that if you wanted to send me an email offline. And let me go to the last page here to get you my email address. And yeah, so I worked with a customer in San Juan Capistrano for the 2-hour discharge test, and he was in direct contact with a representative from the SGIP program. So they pretty much gave the installer all the forms and everything that he needed, and he just wanted me to be with him to set up the system and make sure that everything lasted for the 2 hours and that we were able to appropriately gather the data required for the program. But yeah, as far as an official Schneider document for applying for SGIP, I'm not aware of that, but I can certainly look into it.
Okay. And the next question, is there any way to see the system data viewed on site remotely, or can we only see what Insight shows?
Yeah, so that's another great question. The only way to access the ComBox remotely without Insight is to port forward. So that means we're assigning a static IP address to the ComBox, and then we're using the router's web page to forward that static IP address onto the internet. So essentially we're opening up a port to your local network to the outside world. And that presents a security risk. So if you want to do that, just make sure that you're using a VPN router, virtual private network router. That way, when you do access the IP for that router from a local or a remote location, that it'll be required that you log in, and then it'll pass you on through. So once it passes you through, you're going to connect up to the ComBox login. So that's what we call port forwarding. Highly recommend VPN for security.
And the next question we have, what size breaker is needed in the service panel for an AC coupled XW Plus system? Is there a 20 amp limit on power exported?
So you're talking about, I imagine, the breaker that supplies the XW system in the main panel typically would be 60 amps. That's the breaker rating in the power distribution panel, unless it's supplying other circuits. I guess it could be larger, but yeah, 60 amps is the limit for pass-through on the XW platform, whether we're talking about a single unit or multiple units. And then as far as how much power that you can AC couple, typically you need to observe that 60 amp limit also. So in other words, when you apply NEC 80% rule, it's actually 48 amps is what you can pass through according to NEC, because that's what the breaker's rated at. So 48 amps at 240 is what you can pass through. As far as how much AC coupled power you can have related to the inverter's power, you got to make sure that the AC coupled power does not exceed the continuous rating of the XW inverter. Because what happens is if the grid goes down, and assuming there's no load, then the PV power is going to get pushed through the output into the battery. So if that power level exceeds the continuous rating of the XW, then that will create an overload condition, just as if you had too much load turned on.
And is it possible to AC couple a 6,000 watt grid direct inverter with an XW Plus 5548?
Well, you know, if you rarely get the nameplate out of an array. I usually take the nameplate, multiply it times 80% for poly, 90% for mono, and I'm usually pretty close. So if you do those calculations and you're within the continuous rating of a single XW, whether it's a 5548 or the 6848, then you should be good.
All right. The next question we have, if you are in an off-grid application and the batteries are full, can the XW close a contact to allow for more load to be connected? For example,
Sure.
On a cold day, if there is excess power, I would want to turn on an electric heater using only excess power.
Absolutely. The auxiliary port allows many variations of parameters that you can use to control whether the auxiliary port sends out a signal, which is 12 volts at 250 milliamps. So you can drive an external contactor with that signal to add loads, say when the battery voltage reaches a certain level, or if you're using our battery monitor, you can trigger it on a state of charge. percentage, which is more accurate than voltage. So yeah, you certainly have that ability. Great question.
All right, and we'll move on to our final question here since we're running out of time. But thank you everyone who submitted questions. Our last question, where can I get production wiring diagrams for clustered XW Plus in AC-DC coupled configuration?
Oh, well, the last question was probably the best of all. I thank you all for such relevant questions during this presentation. So just go to sesolar.com and you'll see a products tab where if you hover over it, you'll get a drop down, and then hover over battery-based inverters, move over to the right, and then over to the XW Plus 12240. Click on that, and then you'll see a downloads tab. Click on that, and then you'll see a technical publications tab. Click on that. That's where you'll find the multi-cluster planning guide and the amended multi-cluster design guide. Now the planning guide was the original multi-cluster document, and it has very nice colored diagrams toward the back that you can refer to. The design guide establishes limits for maximum system size and at what point you need to use an external contactor. So for the diagrams, refer to the planning guide. For the latest specs and allowable system wattages as it relates to use of an external contactor, make sure that you are referring to the amended design guide.
All right. Well, thank you so much, Eric, for answering all those questions and a great presentation.
Thank you so much. I appreciate everybody's participation, and again, I appreciate AEE Solar for allowing me this opportunity to share with you today.
Yes, and remember to contact your AEE sales rep for any more questions on the Schneider Electric products we carry, and to place your next order or at least to get a quote. Thank you again for joining us for our presentation on the Conext Insight and ComBox. And don't forget to check our website for more training opportunities with AEE Solar. We've got a lot of good workshops and webinars coming your way. But thank you again. Have a great weekend, and thank you for doing business with AEE Solar. And thank you, Eric.
Thank you, everyone. Bye-bye now.